Welcome. The Passive Sampling Technology Update team is proud to present an overview of the Ceramic Diffusion Sampler. This quick video will provide a high-level overview of the device, as well as instructions on how to use, deploy, and retrieve the device. For more information on this and other passive sampling technologies, please visit the Passive Sampling Technology Update Guidance document. The Ceramic Diffusion Sampler is an equilibrium-type passive sampler to collect volatile and semi-volatile organic compounds in aqueous media while excluding any non-aqueous phase liquid or NAPL that may be present in the water. NAPL can be challenging when sampling aqueous media. Some NAPL may enter or coat the sampler and be included in the sample analyzed by a laboratory. Other passive sampling devices, such as HydroSleeve, passive diffusion bags, and polymeric sampling devices can be contaminated with NAPL, which results in biased results. A fully constructed ceramic diffusion sampler is not currently available from any commercial vendor. The sampler needs to be assembled and prepared by users. The device typically consists of a porous ceramic tube filled with analyte-free reagent water, or DI water, and a PTFE cap. The porous ceramic tube should be submerged in DI water overnight to remove air bubbles, which may influence its equilibration time. Different ceramic tube sizes can be obtained from commercial vendors depending on volume requirements or sampling considerations. Larger sample volumes can be obtained by using more than one ceramic diffusion sampler stacked in series. Prior to field deployment, it is recommended to coordinate with an analytical laboratory regarding the minimum volume requirement for target chemicals. The sampler should be assembled and be ready to deploy with minimum handling of the sampler on site. The sampler should be fully submerged in DI water until field deployment. When ready for deployment, remove the sampler from the container it was stored in after preparation. For deployment in monitoring wells, the sampler should be secured with a rope to the target depth. Reagent water filled inside the sampler gradually leak from the ceramic porous tube. Handling and deployment of the sampler should be quickly conducted to avoid losing the reagent water. During deployment, surrounding chemicals in the aqueous media diffuse through the ceramic tube, and the water inside the tube equilibrates with the surrounding aqueous media over time. The sampler can be retrieved after sufficient deployment time, up to 30 days. To retrieve the sampler, gently remove the device from the sampling media. Any NAPL, residue, or solids build up on the sampler during deployment should be removed with clean wipes. As described previously, water within the sampler can gradually leak over time. Handling and retrieval of the sampler should be quickly conducted to avoid losing the water sample inside the device. Remove an end cap from the sampler and carefully transfer the water sample inside the device into the laboratory-provided bottles. The filled sample bottles should be shipped on ice for laboratory analysis. The main advantage of the ceramic diffusion sampler is the device can exclude NAPL from the collected water sample. Some of the limitations include: the sampler is not commercially available and must be constructed from available parts by the user. The device cannot be used for inorganic chemicals and PFAS due to uptake by the ceramic material, and since the end caps contains a PFAS polymer. Important things to note about the ceramic diffusion sampler: the device can be deployed to NAPL containing media. The sampler must remain in DI water prior to deployment, and the deployment and retrieval of the device must be quickly completed to avoid water loss. Deployment duration should be carefully determined for your target analytes. Extended periods of deployment, typically greater than 1 month, may be needed to achieve equilibration for some chemicals. Remember, you can learn more about the Ceramic Diffusion Sampler and others in the ITRC Passive Sampling Update online guidance document.